supermassive black holes are the source of enormous quantities of gravity, they are not strong enough to bind galaxies together. In reality, the rules of physics dictate that galaxies should accelerate away from one another. So what's stopping them? Because there's something stronger than a gigantic black hole waiting to be discovered. It is invisible and very difficult to detect. It's called dark matter, and it's everywhere. Supermassive black holes discovered by astronomers are found in the centers of galaxies and are responsible for the rapid movement of stars in their vicinity. However, they are insufficient to hold together all of the stars in a vast galaxy. So what does hold them together? It's possible that individual galaxies are also held together by the mysterious substance that's wiki-dubbed dark matter. Galaxies rely on dark matter as a kind of protective framework that keeps them from collapsing and moving about. Now, scientists have discovered that dark matter does more than just bind galaxies together. It may have also triggered their evolution. Scientists believe that after the Big Bang, dark matter started to cluster, and these dark matter clumps evolved into the galaxy's nucleus. However, the nature of dark matter is still a mystery to physicists. Weird things happen with dark matter since we don't know what it is. Obviously, it's not constructed from the same substance that humans are. You can't push against it. You can't feel it. However, it is likely everywhere. It's a ghost-like material that will pass right through you as if you didn't exist at all. Although our understanding of dark matter is limited, it seems to be abundant across the cosmos. That means there must be at least 6 times as much dark matter as regular matter, what humans are comprised of in the cosmos. And the way the cosmos seems to function depends on it. Observations of its effects on light have led to its recent indirect detection in deep space. Through a process known as gravitational lensing, it warps the light. The existence of dark matter may be tested using gravitational lensing. Some distant galaxies indeed seem stretched and warped when seen via the Hubble telescope. The picture distortion is due to the presence of dark matter. We can determine the density of dark matter by carefully examining the forms and degrees of distortion of these galaxies. Now more than ever, the importance of dark matter to the cosmos is undeniable. It's what makes galaxies form and stops them from collapsing. Even though it's invisible and undetectable, dark matter rules the cosmos.
However, there is another theory, most exotic and yet just as deserving as others. What if out there at the edge of the solar system there's an object made of dark matter? We see evidence of dark matter all around us. Stars that revolve too fast around the centers of their galaxy. Galaxies that move too fast within their clusters. A new hypothesis now suggests that most of the dark matter can concentrate into objects the size of Neptune, the so-called dark matter planets. Although these planets remain invisible to us, they can create an atmosphere out of helium and hydrogen. And this can lead to the fact that reaching critical temperatures would trigger nuclear fusion inside the planets, which would help us discover them. Dark matter forming into planets may explain why no object with a mass approximately equal to the mass of Neptune has been discovered in the aforementioned research. Scientists believe that if dark matter planets exist, they clearly formed when the universe was very young and remained static for billions of years. In the early universe, the temperature was too high, which prevented the formation of larger objects. However, dark matter does not interact with ordinary matter nor light and could therefore freely assemble into such, quote, planets. According to this theory, instead of being evenly distributed throughout the galaxy, most of the dark matter will be inside these relatively compact spheres with masses ranging from a mass of an asteroid to the mass of Neptune. These hypothetical dark matter planets may have first accumulated a layer of helium, since it was the first chemical element to break away from the plasma state of the early universe, and later attracted hydrogen gas, creating a dense atmosphere around the helium similar to the layers of gas around giant planets. What would we see inside a planet like that? It's hard to say. Submerging into such a planet would be very strange. A bright layer of hydrogen would be warm since it's gravitationally bound to a dense object. The friction would cause it to glow. After the layer of hydrogen, we would reach the helium underneath, and as soon as we pass through the helium, we would see nothing. Absolute emptiness. The core of the dark matter planet would be completely invisible. You'll find yourself surrounded